Welcome back for our third and final geometry crash course video, where now we do practice. So first, we've got a couple of circle questions. Find the circumference and area of each circle. All right, so you have to pay attention to what they're telling you, especially here since they're not even giving us the courtesy of a figure. A circle with a radius of 6 meters. So let's go ahead and try to draw that. I'm going to zoom in a bit so that way my pictures aren't too big. All right, 6 meters. Okay. So the circumference is 2 times, I'm going to go ahead and put 3.14 for pi times the radius 6. So the circumference here is 12 pi's. And in fancy or later math classes, we would actually write 12 pi meters and then call it good, because mathematicians are weird. But pi is an ugly decimal, so they don't like using the approximation, because in math, they're always like, no, saying 12 pi is far more exact than 37.68. And that is meters. So you just write m or the full word meters. Now the area. Hold on a sec. Okay, so now the area. Sorry about that, I had a quick pause. So the area is pi 3.14 times the radius 6. And I'm going to use the little caret key. That is Shift 6 on your keyboard if you're looking. Or I think on a, might be in a different spot on a cell phone keyboard, but 6 squared. That's what the caret key was for back in the day, was a shift up. So this is now 36 times pi. 113.04. Yes, thank you. I forgot it would do calculations for me. And then this is meters squared. So I'm going to write it like that, but handwriting wise, we usually write m squared, or if you're going to type it, you could write m caret 2, or you can just type it up, meters squared or square meters. But when you are given a unit in the question, your answer needs to reflect the units. So our circumference is a distance, it is meters. Area is a full area, so it's square meters. All right, now we have a circle with a diameter of 24 feet. So I know we just did the thing, and you're like, yeah, I can plug in these numbers, I can do the thing, yeah. Pause, think of every question as a new question. This is one of the ways books, I will say books trick you, because math teachers really don't like doing this. We only do it because the standardized test does it. Like, honestly, there's very few math teachers who are actually that sadistic. Most of us are just like, stupid test. Why did you ask the question like that? All right, so there's our center. Now it said the diameter is 24 feet. So that whole thing is 24 feet. But our area formula at least uses the radius, not the diameter. So our radius here is 12 feet. All right, so our circumference is twice times the radius, which is 24. So 3.14 times 24. We get 75.36 feet, distance around the circle. So 24 feet across, that's pretty big. It's going to be a little over 75 feet around. All right, now we got our area. So area is pi r squared, 3.14 times 12 squared is 452.16. Thank you, magic calculator. Feet. I'm going to put SQFT, square feet. But again, this is also feet squared or feet caret 2. Just make sure you got your units. Now, this is the kind of thing that I could ask you on the test. You fill in the number, or I give you several numbers to choose from, and then I make you fill in the units. So it would be like, is it meters, feet, inches, and then, or is it square meters, square inches, square feet, or is it cubic meters, cubic inches, cubic feet? Like, it's a whole bunch I can put for the selections in the drop-down box there. So just for your consideration for the future, like that's one of the ways I can force you guys to still have to do the units. Because on handwriting tests, like there's not a spot for it. Like there's not something to remind you you need the units. And a lot of people will forget the units. And then the math teachers are like, ha ha ha, you forgot the units, -1 point. I always hated that. So I always told my students, all right, if nothing else on a word problem, write down the units for the answer. If it's money, write me a $sign somewhere. You know, if it's meters, write meters next to whatever the answer is going to be. Or if it's asking for area, square meters or feet squared, whatever. Write me units somewhere and you get a point for writing them. All right, so now we have a radius again. So this is just like number 1. We're going to crunch it through just like number 1. It is even the same units. All right, so circumference is 2 times 3.14 times 8.2. Oh, I have to put a space equals, why for you no do? It's been a long week. There, I needed a space in front as well, apparently. 51.496 for meters. Area, 3.14 pi r 8.2 squared. Okay. So I have 1 decimal place times 1 decimal place will give me 2. 2 decimal places times 2 decimal places for the pi will give me 4 decimal places. That's why I was pausing, is my brain was like, is that the right number of decimal places? Yes, it is. Whereas before, like 12 was no decimal places times 2 would just be 2. In ALEKS, if they want you to round an answer, they will tell you to round it. And anytime that you get decimals, they usually tell you. So like on these, somewhere it will say and round usually to 2 decimal places, but just be on the lookout because they might say just write the whole thing in. Or they'll tell you just use 3.14 for pi and then you type your whole thing in. So be on the lookout for that because you don't want to hit the pi button on your calculator if the direction said just use 3.14. Now perimeter and area. So a rectangle with a length of 4 inches and a width of 7 inches. Methinks they got the labels backwards. Really, it doesn't matter, but if we're going to doodle a picture, length, width, 4, 7. All right, so our perimeter. And you can write this any way you want. If you want to write 4 plus 7 plus 4 plus 7, that's fine. Or if you want to do like the formula I had, 2 times 4 plus 2 times 7, 22 inches. Then our area, Length times width is going to be 4 times 7, which we know, 28 square inches. I'm just going to use the caret, inches squared. All right. So it takes 28 square inches to cover that. So you can think of it as if I took like little tiny pieces of paper that measured an inch by an inch, little inch squares, and I counted how many it took to cover it without overlap, it'd be 28 of them. That's one of the ways area is first introduced to kids is how many of the little Post-it squares do I need to cover this thing? Or how many little squares? All right, so now we have a square. And the side is 5.3 centimeters. All right, so I know one, which means I know the other. So the perimeter is 4 times 5.3, or you could write 5.3 plus 5.3 plus 5.3 plus 5.3, and you get 21.2 centimeters. Now our area. 5.3, 5.3 is the length and the height, the two things that meet in a right angle. But since it's the same thing, we can just be mathematician lazy and write it as squared. We get 28.09 centimeters squared, or square centimeters. All right. So this is only the tiniest bit bigger area than our 4-inch by 7-inch rectangle. So the 5.3, oh, well, that's inches versus centimeters. Never mind, bad comparison. Like we could convert one to the other, but it gets kind of hairy. All right, now parallelogram with sides 5 feet and 12 feet. So let me start with that. So we draw our tilty rectangle. That means these two slanty sides are 5, and then these longer sides on the top and bottom are 12. And then they tell us a distance of 4 feet between the longer sides, the 12-foot sides. So if we're going to measure the distance between these two, like if I was going to whip out my ruler and do it, I would put it so I'm measuring from one line to the other line, and I'd count the distance between. But the way I hold my ruler is at a 90-degree angle. So the distance between two objects, at least two lines, is measured by the perpendicular line segment between the two, if they're parallel. If they're parallel, then this distance between the two is the same everywhere. So that is the 4 feet, and where the 4 feet is in the diagram. So when you have the two long sides, you can actually put the distance between them. But if we tried to write the distance between the two 5-foot sides, there isn't a perpendicular line that will connect those sides. All right. So our perimeter, 2 times 5 plus 2 times 12, 24 and 10 is 34 feet. And then our area is the length times the height. So remember, look for the two things that make the right angle. So it's going to be the 12 and the 4 here. So that's 48 square feet. So you can actually, like if you go to Home Depot, they sell peel and stick laminate tile that is a square foot. So if we were going to try to cover a parallelogram, even though it's tilty with those tiles, if I buy 48 of them and chop some of them up, I can cover it. And then we have 4 triangles. Oh my gosh. All right. So they want the perimeter and area of each one. Oh my goodness. Okay. So let us start with triangle A. Let me zoom back in. So the perimeter of triangle A is, add the sides. 6 plus 8 plus 10. 24. And we have no units. So one of the things you can do is just write unit or square unit, whatever the appropriate dimension is, if you don't have one. But if the problem doesn't give you one, I'm not going to hold you responsible for writing one either. I would prefer to see it, but if they don't tell you, it's kind of hard to do it. Now, area of a triangle is, it's like a rectangle, but I cut it in half. So 1/2, and we'll see if this works, times, and then 6 and 8 are the two that make the right angle, times 6 times 8. Indeed. I'm going to start writing that as u caret 2, and then up here as u on the rest of the problems, because typing it all out is tedious and I'm lazy. Triangle B. Now this is the kind of thing, if we were in class, I would have had y'all like split into some groups, do the thing on your own, check with each other like that. But since we're doing more asynchronous when I'm recording these videos, not so fun. But if you want to pause the video, try it out for yourself, and then come back, feel free. 2.5 plus 1.875, because why not, plus 3.125. All of that comes out to 7.5 units. All right. And then our area, the 1/2, then the 3.125 and the 1.5 are our base and our height. Now, the order you type them in here or write them doesn't matter. So you could write the 3.125 first or the 1.5 first, because multiplication is the same forwards and backwards. And that's square units. All right. So it takes 7.5 to go all the way around, but it only takes, 2.3 and a little bit extra square units to cover it. Not too bad. All right. Triangle C. Stop it! Cats. I hate cats. Same song, second verse. 5 plus 5 plus 8. Those are all the sides around. 18. 1/2 times the 3 and the 8. It's 12 square units. And triangle D. Now, triangle D looks a little funny, but this is why I kept reinforcing it's the two things that make the right angle. But perimeter first. 13, and look, this one's isosceles, the two sides. Even though the picture doesn't look to scale, we go by the numbers written, not the way the picture looks. So since the two 13s are the same, the angles opposite those are also the same. I'll doodle those in real quick for you. That angle and that angle are the same. So our 5 length segment here is actually cutting the triangle in half perfectly, area-wise. All right, so 13 plus 13 plus 24. 50. Cool. And then the 90-degree angle. The base does not have to be the one that's on the ground. That's why this triangle is drawn this way, and it's in the notes, is to reinforce that the base is not just the one we put flat on the ground. It's whichever two things make the right angle, those are the base and the height. It doesn't matter if neither of them are on, you know, a perfect flat or a perfect straight up. So the 24 and the 5. So the 1/2 times 5 times 24. And we get 60 square units. So there it is. The down and dirty crash course of geometry. You will probably still see some slight word problems, but they're not going to be, they shouldn't be super crazy. If any of the word problems like freak you out when you start to do the homework on this, shoot me an email. I will go in, dig one out, and show you an example of it, because I don't want you guys to freak out on a word problem. Like, freak out too much, I guess I should say. There is a reason why your gut might have that fear of them, and that's because mathematicians do not write English well. Not to say that they're all international, although ironically most college math professors are, but that we speak in math, we don't speak in colloquial English. And the way we say something in math is not always the same way you would say it in English, but it's the English people who get the job as editors for math textbooks. So that is who I blame for really bad word problems. Sometimes the math teacher just writes it bad. I've done that myself. So if I write a problem and you're like, I don't understand what you said at all, you let me know, because it might mean I wrote it wrong. And I freely admit that happens. All right. So that is it for geometry. Chin up, keep calm and carry on. Stay safe and keep warm. I shall see you soon. I will have office hours on Wednesday, but no classes on Tuesday. Tomorrow, the day after tomorrow, sorry. That's the 23rd.